Hi, this is Math 7, Unit 6, Lesson 17, Modeling with Inequalities. It says Elena is trying to figure out how many movies she can download to her hard drive. The hard drive is supposed to hold 500 gigabytes of data, but 58 gigabytes are already taken up by other files. Each movie is 8 gigabytes. Elena wrote the inequality 8x plus 58 is greater than or equal to 500 and solved it to find the solution x is greater than or equal to 55.25. Explain how you know Elena made a mistake based on her solution, and then fix her inequality and explain what it actually means. So this is the cool down for you to do on your own based upon today's lesson, so I'm going to let you work on that one. Number 2, Kieran is packing boxes to be mailed to soldiers overseas. 9 of the boxes can hold the same amount of weight. What is that? We don't know. The 10th box holds 14.5 pounds. The weight of the 10 boxes cannot exceed, that means it needs to be less than 100 pounds. Now, can it be equal to? It can be equal to, it just can't go over 100. So let's write an inequality here. What do we know? We know that 9 boxes, we can call them B, 9 boxes have something in them, some weight, all the same, plus a 10th box, which we know weighs 14.5 pounds. Those all combined need to be less than or equal to 100 pounds. Now, can we solve that inequality? Sure, we certainly can. So we're going to do 9b plus 14.5 is less than or equal to 100. We'll subtract 14.5 from both sides. So this goes away. So 9b is less than or equal to, let's see here, I'm going to borrow there. So we have 5. 9 minus 4 is 5. 9 minus 1 is 8. So we have 85.5. Divide both sides by 9. So that b has to be less than or equal to what? 85.5 divided by 9 is equal to 9.5. So what does this solution actually mean? So we're going to explain it here. This solution means that the weight of the boxes, each box needs to be less than or equal to 9.5 pounds. If it was more, it wouldn't work. For example, if I had a 10-pound box here, well, 10 times 9 is 90 already. If I add 14.5 to it, now I'm at 104.5 pounds, and that's greater than 100. It breaks the rules. So it needs to be less than or equal to 9.5. So make sure you explain that in some words. Number 3, Priya buys a candle that is 12 inches tall. Way to go. The candle burns at a rate of X inches per hour. She wants the candle to burn for 4 hours until it is less than 6 inches tall. Write an inequality whose solution is the possible inches per hour the candle can burn. Alright, so we know it starts at 12, right? Okay, so whatever the 12 is, that's where she's starting at, and it's going to burn. She wants the candle to burn for 4 hours until it is less than 6 inches tall. So we want this to happen until it gets to the point where it's less than 6 inches. Okay, so we're going to do 12, and we're going to subtract from it the 4 hours minus whatever the rate is going to be. I don't know what that's going to be. So we might have an inequality that looks something like that. We would then work to solve that and explain what that's going to be. Alright, so I'll let you do that one there. Number 4, Andre has $90 to spend on buying new shoes and socks. He finds a pair of Vans for $65, so we have 90 bucks, and needs to buy socks. Socks cost $2.50 a pair. How many pairs of socks can he buy? Well, so what do we know? He's going to take his $65. He's going to add to it the cost of socks, which is $2.50 for each pair of socks. We don't know how many. We'll call them X. And whatever that is altogether, it needs to be less than or equal to $90 because that's all the money he has. So now let's solve it. Sure. 65 plus 2.50x less than or equal to 90. We're going to subtract 65, subtract 65. So 2.50 is less than or equal to, well, let's subtract here. We got 5 and 2, 25. So we divide 2.5 right there. And 25 divided by 2.5 is equal to 10. Oops, I forgot my x there. Sorry about that. So x is less than or equal to 10. So the number of socks you could possibly buy is going to be less than or equal to 10 before he runs out of money. Let's look at the back side. All right, these are our review questions. An antique store pays $130 for a mirror, and it resells it for 50% more than the original amount. How much would they pay? Well, again, you're selling it for 50% more than the original, which means if you take the original, okay, and then we add to it 50% more to the original, that's what we're talking about. Now the original is 100%, that's the original cost, plus 50% more. So what we want to know really is 150% of the actual original cost. So this becomes, move the decimal 2 spaces, 1.5 times 130 will be 150% of the original cost. So I multiply that out, and we find out that the resale on that is going to be $195. That's 50% more than the original. A couple ways of doing that again. This is the one way. I could also do 50% of 130, right? So 130 times 0.5, and 50% of 130 is 65, and I would add that to the original amount, 130, and you end up with what? The same number, 195. So both methods work and both are fine, depends on what makes the most sense to you. Alright, Tyler goes to Red Robin for dinner. I was just there the other night. Don't go there often, but I went there the other night. He has an appetizer for $6, a steak dinner for $16, and a soda for $2, and a piece of pie for $5. Wow, hungry guy. He plans to tip his waitress 15%. What is the total of Tyler's meal before the tip? So you want to go ahead and add up the different prices there. Okay, we're going to add the prices there. Then how much is 15% of this tip? Okay, so you're going to take your answer from A, okay, whatever this answer is here, and we're going to multiply by what? Multiply by 0.15. That's the tip. Now the total is going to be what? It's going to be his total from A plus the tip from B, and that's going to be how much his total bill is going to be. You take this amount that you find, add it to this amount, and that gets your total. Number 7, here's a chart showing the difference between Andre and his brother's age. Alright. Is Andre's age proportional to his brother's age? Explain your reasoning. Alright, so we have in 2015, one was 8, one was 12. 5 years later, they become 13 and 17. And then 5 more years later, 18 and 22. Is this proportional to his brother's age? That's a great question. So I'm going to let you decide. What do you think about that? Is this a proportional relationship? Helps if you remember what makes something proportional or not. So look at what's happening there and explain your reasoning. The last one. Does the table show a proportional relationship? Explain your reasoning. Okay, so helps sometimes if you look to say, decide, is this a proportional relationship? So 12, think about your y over x values. 12 over 8. Well, 12 over 8 is the same as what? That becomes 4 goes in here 3 times, 4 goes in there 2 times. That's pretty good. How about 15 over 10? 15 over 10. 5 goes in here 3 times, 5 goes in here 2 times. Alright, so really we're looking at 1.5. How about 13.5 over 9? Now that's one I don't know about too much. If I take a calculator, do 13.5, and I divide it by 9, I actually get 1.5, which is the same as this, 1.5, 1.5. So what I see is that there is a proportional relationship because every value in x, if I multiply it by 1.5, I get the value of y. Okay? So this is why we would say that looks like a proportional relationship to us. Alright, that's it for today. Have a great day, and we'll see you next time.